Hello everyone, this is the second part of question 3 of the DBE November 2019 Physics Paper 1. So for this question, it's a continuation of the previous question where we had two stones being thrown off a building at different times. So we are given the position versus time graph for the motion of both of the stones. And we can see on this graph that on the y-axis, we have the position in meters, and on the x-axis, we have the time in seconds. So we can work out from this graph that at time d, so if we say the top line is rock A and the bottom line is rock B, A and B, because we know that A was thrown off the building and it went up to reach a point and then it went down until it hit the ground, and stone B was just dropped off the side, so it would have gone like that. I also drew that in the previous question. I showed you that stone A went up and then down, and stone B just went straight down. So this is what it would look like on the position versus time graph. So from this graph, we can tell that at time D, stone A is at height H. At time E, stone A is at a height of A. We can see like this, it goes nicely. And at time F, stone B is at time B. And is at height B, sorry, position B. And at time G, both stone A and B are both at position C. So at position C, this was when they met and then A overtook stone B. Stone A overtook stone B. So now we have got a few questions on our graph. Let me just rub this out. So again, stone A is the top one and stone B is the bottom. This is because our building was like this. Stone A was thrown up. It reached a point where its velocity equaled 0, and then it fell to the ground. So stone A did this. And stone B was just simply dropped off the building. And we know that stone B was dropped off the building. We worked out it was 1.34 seconds after stone A was thrown off the building. So this amount of time, the time from 0 to F is 1.3 seconds. 1.34 seconds. Okay. And then we could also work out what the time from F to G is from the total time of A that we worked out in the previous question minus 1.34 seconds, but we don't need to do that. So we are going to go into the questions now. The question says, which of labels A to H on the graphs above represents each of the following? So 3.5.1, they're asking which label on the graph represents the time at which stone A has a positive velocity. So when does stone A have a positive velocity? So that means when is stone A getting faster? When is stone A traveling upwards? Its velocity is going upwards because we decided that upwards would be positive. And we also presume from this question that upwards is positive. So what time is stone A traveling upwards? and we can see from our graph, from the graph and from the drawing that stone A goes up in position and then it goes down in position. So if this was a velocity versus time graph, it would probably look like this. If we had velocity versus time, it would go decreasing in velocity till it gets to zero, and then decreasing more in velocity because it's going downwards. Okay, so this is going upwards, and this one is going downwards because its velocity is increasing downwards as we're going towards the ground. So when on our graph, does stone A have a positive velocity? When is stone A going upwards? At point, and at what time is it? So we know, okay, over here, I told you that the velocity equals zero. So that's not a positive velocity because zero is not positive, zero is not negative either. So it's not E. Um, if I told you it's going down, so that's a negative velocity, so it's not that one either. G is also going down, so it's also not G. D, we're at point H. We're traveling upwards here with the rock, so must be D. So the answer for 3.5.1 is D. So at point D, at time D, the stone has a positive velocity. Just remember when you're answering these questions, make sure that you um know what they're looking for. Do they want the time? Do they want at what position? Just double check that you are doing the right thing. Okay, now they're asking for the maximum height reached by stone A. So we have position versus time. Position and height are basically the same thing. So where is the position of stone A the highest? And we don't want at what time is stone A at its maximum height? We just want where is the maximum height. So we can see here the highest point that stone A goes to is at point A, is at label A. So the answer is A. Okay, so we've had D and we've had A. Now we are going to look more at stone B. Okay, rub these out. Okay, so stone B was dropped off after stone A. Okay, and I said that this was B and this was A because of the last question. Okay, so what is the time at which stone B is dropped off? Stone B's graph only starts over here at F. That is telling us that there was no movement of stone B before time F. So before time F, stone B was at a standstill, the person was holding it, it was on the ground, something like that. So movement started at time F, which means that time F is the time when stone B was dropped. Okay, if they asked us at what height was stone, at what position, or what height stone B was dropped at, then that answer would be position B. If they also asked us what is the maximum height reached by stone B, the answer is also position B because stone B doesn't go up and down, it goes straight down. So the highest point that it reaches is the point that it's thrown from, that is dropped from. Okay, so the answer for the time that stone B was dropped, not the height, not the position that stone B was dropped at, the time that stone B was dropped is at time F. Okay. Then our last question is the height at which the stones pass each other. So stone A thrown up goes down. Stone B dropped after A and goes down. Over here at the bottom, can we see that they are meeting? They're at the same time, at the same position. So they're at the same position at the same time. Therefore, that's when they are meeting. So when do they pass each other? They pass each other when they're meeting. So they meet for a split second and then they pass each other. So they basically pass each other when they meet each other because it's so quick. So the time when they pass each other is time G, but we're asked for the height at which the stones pass each other. So we go up from time G over there, and we can see that the position in meters is we at C, at the label C. So the height, which is also in meters, so it's also the position, is C. So answer is label C. Yeah, and there we have it. 4 nice, easy marks. Thanks, guys. I'll see you for the next question.